Time rules everything. Our thoughts, our breath, our lives, all carried forward by an invisible current we never question. But what if that current doesn't always move forward? What if, somewhere beyond the veil of our known universe, time flows in reverse, not metaphorically, but physically, fundamentally? Imagine a place where stars undetonate, where people unage, where causes follow effects, and the future gives birth to the past. A reality where the arrow of time, so rigid in our world, bends backwards without resistance. Strangely, the laws of physics don't strictly forbid this. In fact, they may even expect it. Deep within the framework of quantum mechanics and cosmology lies asymmetry that whispers of mirror realms, of twin timelines, unfolding in opposite directions from a single origin point. If such a universe exists, what would it look like? Could we ever detect it? Or has it already touched us in ways we don't yet understand? Time doesn't knock when it enters your life. It's already there, embedded in your heartbeat, the flicker of light across your retinas, the quiet erosion of memory. It's in the dust on your bookshelf, in the cooling coffee on your desk, in the laugh lines around your eyes. To us, time feels like gravity, constant, invisible, impossible to fight. But unlike gravity, time isn't something we've ever truly understood. We feel it. We measure it. But what is it? We live inside a one-way tunnel called now. The past is unreachable, the future unknowable, and yet we move through both every second. Ask a child what time is, and they'll point at a clock. Ask a physicist, and they'll pause. Because what time is, and why it moves forward, is still one of the deepest mysteries in science. But we do know this: time moves. And it moves in a specific direction. You remember yesterday, not tomorrow. You can shatter glass, but you can't unshatter it. A hot pan cools on the counter. It never spontaneously heats itself. There is a current to time, and it only flows one way. This direction is what physicists call the arrow of time. But what sets that arrow in motion? Let's start with the human experience. Our sense of time is rooted in memory. Without memory, there is no past. Without anticipation, there is no future. The arrow of time is carved into our biology. Our brains build stories by stacking moments in order, like beads on a string. The string only makes sense if the beads follow a pattern. Neurologically, our brains are prediction machines. When we walk down a street, we expect continuity, that each step forward leads us deeper into the future. If our steps suddenly led us to yesterday, the illusion of reality would collapse. What we call normal is just a long, unbroken thread of expectations met. Even our bodies obey time's commands. We age. Cells divide, falter, and die. Muscles wear out. Hair turns gray. We never meet an older version of ourselves in the mirror. Time marches forward inside every cell we own. Yet, biology is not where the mystery ends. In fact, it only begins there. Behind our lived experience, there's a hidden force pushing the arrow forward: entropy. Entropy is a term from thermodynamics, the physics of heat, energy, and change. It describes the level of disorder in a system. A glass of water, neatly placed on a table, has lower entropy than that same glass shattered across the floor. The universe tends to move from order to disorder, from structure to chaos. This tendency, the second law of thermodynamics, is the most unbreakable rule we've ever discovered. And it may be the very reason time appears to flow. Imagine a deck of cards shuffled perfectly into order, ace to king, each suit neatly stacked. You toss the deck into the air. The cards scatter. You collect them again. They're a mess. The universe, in this analogy, is the deck. Time is the act of shuffling. Entropy is what happens when the neat gives way to the messy. This is why cream mixes into coffee, but never unmixes. Why houses collapse in earthquakes, but don't spontaneously rebuild. Why we die and don't come back younger. Entropy doesn't care about feelings. It increases, always. And as entropy grows, time moves. But here's the twist. The laws of physics, at their core, don't demand this. Most equations governing the universe, from Newton to Schrödinger, are time symmetric. That means they work just as well forwards as backwards. A planet orbiting a star looks physically valid whether you run the tape forward or rewind it. But entropy doesn't. It points only one way. So, what gives? Why does everything else in nature play fair with time, while entropy alone demands direction? One theory is that the arrow of time was forged at the moment of the Big Bang, a moment of incredibly low entropy. From that dense, ordered state, the universe began its journey toward chaos. Galaxies formed, stars ignited, planets cooled, life emerged. In every step, entropy rose. But why did the universe start in such a weirdly ordered state to begin with? It's like walking into a room and finding 10,000 dice all showing the number 6. Not impossible, just wildly improbable. If entropy defines time's direction, then the low entropy birth of the universe may have written time's arrow into existence from the very beginning. And yet, that explanation feels like a cheat code. Why should the birth of the universe be so special? Why only one arrow? Why only forward? Some cosmologists whisper of deeper symmetries, hidden structures where time isn't broken, but balanced, where the arrow isn't one way, but split. But that is a thought for later. Here's the paradox. Time rules us, and yet we cannot touch it, trap it, or even see it. Clocks don't measure time, they measure change. The ticking of gears, the oscillation of atoms, the rhythm of vibrations. But change is not time. It is the footprint time leaves behind. Is time a dimension? A property? A trick of perception? We don't know. What we do know is that we live under its rule. Our minds insist on time's arrow. Our bodies decay with it. Our world grows more chaotic by the second. Entropy grows. And with it, our sense of before and after. But maybe, just maybe, all of this is local. A trick of our side of the universe. A biological illusion. A thermodynamic preference. What if somewhere else, time flows in the other direction. Not because of memory or biology or entropy, but because the rules are written differently. Could such a place exist? Would its inhabitants remember their deaths before their births? Would a star there shine backward into the past? Would time itself be inverted? We've followed the arrow forward our whole lives. But now we turn around and ask a forbidden question. What if forward isn't the only way time can go? The universe has always been a place of symmetry. From the way atoms behave to how galaxies dance across the cosmos, symmetry whispers beneath the chaos. In physics, symmetry isn't just aesthetic, it's law. It governs the way particles interact, how forces behave, and how the rules of the universe remain consistent across time and space. And yet, one strange exception keeps gnawing at our understanding: time. Nearly every fundamental law of nature is time symmetric. That means if we took a film of two particles colliding and ran it backward, the laws of physics wouldn't complain. Newton's laws, Maxwell's equations, Schrödinger's wave function, all of them would hold true whether time moved forward or backward. So why, then, does time seem to care which direction it moves in when the math doesn't? To understand this, we must journey into the heart of symmetry itself. In the language of physics, there are three core symmetries: charge, C, parity, P, and time, T. Charge symmetry means the laws of physics remain unchanged if particles are swapped with their oppositely charged counterparts. Parity symmetry means the universe should behave the same if all spatial coordinates are flipped, like looking in a mirror. And time symmetry means the laws should remain consistent, even if time is reversed. This triumvirate is at the core of what physicists call CPT symmetry. Individually, these symmetries don't always hold. In the 1950s, scientists discovered that weak nuclear interactions violate parity, P symmetry. That was a shock. Later, it was revealed that charge, C symmetry, could also be violated. But combined, CPT symmetry still stood strong. In every known experiment, the laws of physics remain invariant when all three are flipped at once. This unbreakable balance suggests a deeper truth. Even if time appears to flow forward here, it may not be fundamental. It may only be half the story. Think of CPT symmetry like a cosmic mirror. On one side is our universe with its familiar arrow of time. On the other side could exist a mirror universe where particles are oppositely charged, spatial coordinates are reversed, and time flows backward. Not as fiction, but as a mathematically valid consequence of the universe's most sacred symmetries. What would this mean? In that mirror cosmos, entropy would decrease. Stars would contract from dispersed gases. Light would converge into singular points. Death would be the beginning, and birth the finale. But to those inhabitants, none of it would seem strange. Their consciousness would still align with their own direction of time. They would remember the future and anticipate the past, just as we do, only flipped. This brings us to a disturbing and exhilarating implication. Perhaps time is not absolute at all. Perhaps the direction we perceive is just a consequence of initial conditions, the same way a ball rolls downhill, not because it must, but because it started high. Our universe began in a low entropy state. If another began in a high entropy state and rolled the other way, time would still make sense from the inside. But how would we ever know? Can we test the symmetry of time? Quantum mechanics, ever the rebel, may hold the answer. Deep within the realm of quarks and leptons, subtle violations have been observed. In 1964, scientists witnessed a rare phenomenon, CP violation in the decay of kaons, short-lived particles made of quarks. This hinted that even combined charge and parity weren't sacred. And if CP is violated, then time, T, must also be violated to preserve CPT symmetry. This was revolutionary. It means that, at the quantum level, the universe does distinguish between forward and backward time, but only slightly. These violations are minuscule, barely detectable, and only show up under extreme conditions. Still, they offer a crack in the armor of time's invincibility, a sign that the universe might harbor a bias, however slight, toward a specific direction of time. But here's where things get stranger. If CPT symmetry demands a mirrored cosmos with reversed time, then the Big Bang itself might be the hinge between two universes, ours moving forward and another moving backward. A twin cosmos born from the same explosion, expanding in opposite temporal directions. We perceive the Big Bang as the beginning, but for another realm, it might be the end. Two universes joined at a singularity, each flowing away from the other in time. This idea, proposed by physicists like Julian Barber and Sean Carroll, suggests a bidirectional universe. From a distance, it's symmetric. From within, each half experiences its own time arrow. In this framework, time isn't universal. It's local. Just like velocity or temperature, it depends on your position in the larger system. If true, this would rewrite everything. It would mean the universe is far bigger than we imagined, not in space, but in time. A double-sided tapestry, woven from mirrored threads of existence. But can this be more than theory? Can we detect this shadow universe? In 2018, researchers studying neutrinos in Antarctica's ANITA experiment reported puzzling results. Particles appeared to emerge from Earth's surface, traveling upward, something standard models couldn't explain. Some speculated it could be evidence of a time-reversed particle from another realm, something crossing over. Though the result remains controversial and alternative explanations exist, it awakened public imagination. Could particles leak between temporal directions? Others looked to cosmic background radiation, the afterglow of the Big Bang, for clues. If a mirror universe exists, perhaps it left an imprint in the primordial light. Irregularities, cold spots, or unusual symmetry in the CMB could hint at a reflected cosmos just out of reach. Even more daring ideas suggest quantum entanglement might be a bridge. In entanglement, particles influence one another instantly across space. But what if time is also in play? Some researchers propose that entanglement is possible because particles are linked across time, one moving forward, one backward. A handshake across arrows. Of course, these theories live on the edge of what science allows. they remain speculative, unconfirmed. But they are not wild fantasies. They stem from the deep symmetries of physics, from observations that refuse to fit tidy narratives. And so, we are left with an unsettling possibility: time, that most sacred of flows, may not be universal. The arrow may not point one way. Our entire cosmos may be but one half of a greater whole. Somewhere out there, beyond reach, another reality could be ticking backward, unaware of us, just as we are of them. And if that's true, then what we call the beginning might only be a boundary, a door to a mirrored realm where time itself dares to turn and walk away. Imagine this. At the center of all existence lies a single moment, not an origin, not an end, but a mirror. A point of perfect balance where all the laws of physics align in such a way that they don't prefer one direction of time over another. From this equilibrium, two universes unfurl, one flowing toward what we call the future, and another moving in the opposite direction. Time splits like a fork in the river of reality. One stream carries us forward. The other flows backward. This is the provocative heart of the Janus point theory, proposed by British physicist Julian Barbour. It suggests that the universe did not begin at the Big Bang and head linearly toward decay. Instead, the Big Bang is the Janus point, named after the Roman god with two faces, a place where the universe emerges in two opposite temporal directions. Each side experiences the arrow of time, just not in the same orientation. If true, then right now, in the unfathomable distance beyond what our telescopes can see, another universe could be unfurling, a mirror to ours, a cosmos where time runs in reverse. But what would such a universe look like? To understand this strange mirror realm, we must shed our intuitive notions of causality, identity, and motion. In our universe, we are born, we age, and eventually we die. Time marches forward with relentless indifference. Entropy, the measure of disorder, increases with every passing moment, aligning our experience with the laws of thermodynamics. But in a universe flowing backward from our perspective, these familiar concepts break down. There, people would seem to unage. They would appear to rise from graves, grow younger over decades, return to childhood, and ultimately dissolve into the womb, though from their point of view, they would be experiencing life normally, just like we do. Their sense of time would feel as natural to them as ours does to us. We would see them in reverse, but they would see us the same way, like strange beings living life backward. It's a staggering concept, not because it defies science, but because it so deeply challenges our perceptions. In a time-reversed universe, entropy would decrease. Structures would become more ordered over time. Stars would absorb radiation and grow hotter. Gas clouds would converge into symmetry. And perhaps most bewildering of all, causality would appear inverted. In this mirror, cosmos, events would seem to occur before their causes, at least from our vantage point. A shattered cup might leap from fragments back into form. A burnt forest might regrow before the match is struck. But for its inhabitants, all of this would seem perfectly ordinary. Their brains, processes, and memories would function within that framework. To them, we would be the ones moving backwards, degenerating into youth, assembling destruction, lighting fires after the smoke has cleared. If both universes stemmed from the same Janus point, then their time directions are not inherently superior to one another, just opposite. Each would believe it was moving forward in time. Both would experience increasing order from their own beginning. Yet to one another, they would appear to be heading in reverse. What does this mean for identity? For consciousness? Could someone exist in both universes? Or transition from one to the other? To address this, we must revisit the nature of information. In our universe, information seems to flow with time, from past to future. We remember the past, but not the future. But in the reverse time universe, beings might remember what we call the future, perhaps not in the way we imagine, but embedded in their cognition and biology. Memory, after all, is a physical process tied to entropy. If entropy decreases there, then maybe memory works backwards. This could mean that our mirror counterparts might remember events that, to us, haven't happened yet. Not because they see the future, but because their future is our past. This would lead to a fundamental inversion of cause and effect. Let's take it a step further. What if this mirror universe isn't entirely separate from ours? Barber's theory doesn't demand that the two universes remain forever disconnected. If both share the same origin point, the Janus point, then they may be entangled in some way. Not quantum entanglement, but a deeper symmetry. One where the shape and structure of both universes reflect each other like folded pages in a cosmic manuscript. Perhaps large-scale fluctuations in one affect the other. Or maybe, in the deepest parts of space, at the coldest and most ancient corners of the void, the two universes brush past each other like ghost ships, aware only through the faintest of ripples. If such contact were possible, what would happen? It may be that interaction between forward and reverse time systems is fundamentally impossible. Their entropy directions would be incompatible. Energy transfer would break down. Matter might unravel at the boundary. Consciousness might collapse. But it's also possible that they influence each other subtly, like gravitational waves passing silently between realities. We wouldn't notice them directly, but maybe, just maybe, they're responsible for some of the strange asymmetries we observe, the unbalanced expansion of the universe, the irregular clumping of matter, or even the unexplained patterns in the cosmic microwave background. And what about death? In our reality, death feels like a one-way door. But in the time-reversed universe, from our perspective, people would appear to emerge from death. They would lie in tombs, then rise, age in reverse, and be reborn. Of course, to them, none of this would seem strange. But to us, it would resemble resurrection. Could this be the root of some of our oldest myths? Many ancient cultures speak of time flowing differently in the afterlife, of gods and spirits who move in strange rhythms. Could the idea of a reverse time universe have echoed into our collective unconscious? Maybe the concept of reincarnation, of cyclical time, of life returning from decay. These are fractured reflections of a reality that exists beyond our thermodynamic bubble. There's a final twist to the Janus point theory. If the universe is truly symmetric in time, then our fate is not a cold slide into heat death, as classical physics suggests. Instead, we may be journeying towards something profound, a mirror of our own origin. The structures we build, the complexity we create, could be mirrored in reverse. And somewhere on the other side of the cosmic mirror, an entire civilization might be building its own complexity, its own destiny, in the opposite temporal direction. We may never meet. We may never understand each other. But in the grand equation of the cosmos, we might be part of the same solution, two arcs of time, expanding away from a single breath of creation. A universe in reverse is not just science fiction. It's a possibility rooted in the very equations that govern our reality. And if such a universe does exist, then somewhere out there, right now, a person might be watching a sunrise fall below the horizon, seeing the stars dim one by one as time guides them gently into a younger world, back to their beginning. If a time-reversed universe exists, the obvious question is, where is it? We've built machines that can detect the faintest whispers of radiation from the birth of our cosmos. We've mapped galaxies billions of light years away. Yet, in all our cosmic treasure hunting, we haven't found clear, undeniable signs of a mirror world where time flows in reverse. Or have we? In 2016, something strange happened over the icy landscape of Antarctica. A high-altitude NASA experiment known as a NIT, the Antarctic Impulsive Transient Antenna, was scanning the skies for ultra-high-energy cosmic neutrinos. These are ghostly particles that pass through most matter undisturbed, and ANIT was looking for the rare cases when they didn't, when they slammed into Earth's atmosphere and produced detectable signals. But ANIT picked up something bizarre. A particle appeared to emerge from the Earth, not from space, but from below. It was as if a high-energy neutrino had traveled up through the planet and exploded into detectable signals in the air. That's not supposed to happen. Neutrinos can pass through Earth, yes, but ultra-high-energy neutrinos are far less likely to do so. At that energy, a particle should have been stopped somewhere in the crust or mantle. And yet, there it was, moving in the wrong direction, as if time itself had flipped. This event, and a few others like it, sparked a wave of speculation. Could this be a particle from a time-reversed universe? Was this a rare case of our universe, and a mirror, one briefly touching, just enough for one of their particles to stumble into our realm? A group of physicists proposed a radical idea that what a NITA had detected was a tall neutrino, but not one born in our universe. Instead, it may have been part of a mirrored reality where time runs in reverse. In this alternate domain, particles might normally move upward toward what they see as the future, which would be our past. The media caught wind of it, and headlines exploded with claims like NASA detects evidence of a parallel universe. But the scientific community, always cautious, was less convinced. There are other explanations for the anomaly. Some believe the particle's trajectory could be explained by complex interactions in the ice or experimental noise. Others think it may be evidence of new physics, but not necessarily a reverse time universe. Maybe it hints at unknown particles or forces that we simply haven't accounted for yet. Still, the ANITA anomaly won't go away. It lives on in physics papers and whispered conversations between cosmologists late at night. Because whether it's truly evidence of a time-reversed universe or just a glitch, it reminds us of how much we don't know. And it's not the only oddity. Take the cosmic microwave background, the leftover glow of the Big Bang. It's incredibly uniform, like a soft fog that blankets the sky. But hidden within it are tiny fluctuations, and some of these appear lopsided. There's an axis, often called the axis of evil, where temperature anomalies seem to line up, hinting at a strange asymmetry. If our universe is symmetrical in time, why would it have a preferred direction in space? Some theorists suggest that this asymmetry could be the fingerprint of something outside our observable cosmos, perhaps even a neighboring, time-reversed universe nudging ours ever so gently. Not directly, but gravitationally. Cosmological twins influencing each other from opposite ends of the time spectrum. Another strange clue comes from the baryon asymmetry, the fact that our universe has more matter than antimatter. According to our best models, the Big Bang should have created equal amounts of both. Yet, here we are, made of matter, with almost no antimatter to be found. Could a time-reversed universe hold the missing antimatter? If one universe evolved toward the future with a surplus of matter, perhaps its mirror evolved with a surplus of antimatter. It would explain the imbalance. We would be matter in one direction, they, antimatter in the other. But again, this is speculation. Elegant, compelling, but far from proven. The problem isn't just finding evidence. It's interpreting it. We are creatures bound to one direction of time. Our instruments, our models, even our logic, they all assume time flows forward. How do we detect something that runs counter to our every assumption? Imagine trying to recognize a river flowing backward if all your senses were calibrated for only one direction. The backward flow would look like noise, like error, like something broken. And maybe that's the point. Maybe we've already seen signs of a reverse time universe, not in the grand discoveries, but in the anomalies we dismiss. The inconsistent data, the unexplained blips, the observations that don't fit. Science, at its heart, is a process of pattern recognition. But what if a mirror universe doesn't fit our patterns? What if it's too alien, too inverted, to even be perceived as real? Even if we did find solid proof, a particle, a signal, a burst of reverse entropy, how would we know what it means? Would we recognize it for what it is, or misinterpret it as a fluke? In recent years, theorists have begun to explore the possibility that the universe we see is only one part of a much larger structure, a time-symmetric multiverse, where each universe is born at a Janus point and expands in opposite directions of time. These universes might be inaccessible to one another, but they might leave gravitational imprints, subtle warps in space-time, strange lensing effects, or even unexplained forces acting on the motion of galaxies. Some even speculate that the dark flow, a mysterious drift of galaxy clusters, could be evidence of another universe's gravitational tug. One we can't see, but which might be right next to us, flowing backward. In the end, we're left with a tantalizing question. Are we alone in time? We often ask, whether we're alone in space, whether alien life exists on distant planets. But maybe the more profound question is whether we're alone in temporal direction, whether another entire cosmos exists alongside ours, unfolding in reverse, as real and complex as our own, yet forever invisible to us. The clues may already be here, hidden in the noise, waiting for someone or something to look at them backward. We measure time in seconds and minutes, in orbits and oscillations. But what really marks the passage of time in our lives? Memory. Without memory, the past vanishes. Without anticipation, the future dissolves. Our consciousness stitches these fragments into a narrative. We remember what came before. We imagine what might come next. But what if that entire framework, past, present, future, is just a story we tell ourselves? A side effect of how the human brain evolved to perceive reality? And what happens to consciousness in a universe where time flows the other way? Imagine a mind in that world, a being born in what we call the future, experiencing events in reverse, dying before it lives, remembering things that haven't happened yet to us, and forgetting what we would call the past. Would such a being feel like it's living backward? Or would it, like us, feel perfectly normal? This opens a staggering possibility. What if the direction of time we perceive is not dictated by physics alone, but by consciousness itself? Could the flow of time be subjective, tied to how awareness threads moments together? Modern neuroscience offers fascinating clues. Our brains don't process reality in real time. It takes roughly half a second for information from our senses to become conscious experience. Yet, we feel as if we're living in the now. We feel a seamless stream of awareness, even though the brain is constantly editing, buffering, and smoothing. Now, imagine a brain wired in the opposite temporal direction. It would receive signals from the future, process them, and generate conscious experience anchored in what we call the past. But to that being, its future is our past, and the narrative it builds would make just as much sense to it as ours does to us. In this view, consciousness is less like a spotlight moving forward and more like a film editor assembling footage into a coherent story. Whether that story runs left to right or right to left may depend more on which side of the cosmic mirror you were born on than any absolute rule. Some philosophers have taken this idea even further. They argue that consciousness may not just experience time, it may generate it. The famous physicist John Wheeler once proposed the concept of participatory anthropic principle, suggesting that observers are not just passive spectators of the universe, they create its history by observing it. In quantum mechanics, this is echoed in the observer effect, where the act of observation affects the outcome of an event. Could it be that time itself, the entire sequence of cause and effect, emerges from the structure of consciousness? If so, then beings in a time-reversed universe wouldn't just adapt to reversed time, they'd actively construct it. Their brains would be quantum engines, weaving a causal web from their version of now to what we call before. To them, our world would look bizarre, people aging instead of getting younger, causes following effects, death preceding birth. But they wouldn't see it as backward, only different. This brings us to an eerie possibility. Could reverse time consciousness be interacting with us already? Some physicists working in the field of quantum retrocausality speculate that certain quantum effects involve information traveling backward in time. If consciousness is somehow tied to quantum processes, as some theories of consciousness propose, then perhaps there's a form of awareness that stretches across time in both directions. Think about those rare, fleeting experiences we all have: déjà vu, strange premonitions, an unexplainable sense of knowing what's about to happen. Are these glitches in the brain, or are they brief collisions with another kind of awareness? One that sees time not as a road, but as a landscape, where both past and future are visible at once. And if consciousness can transcend time, or even run opposite to ours, what would communication look like? Picture a reverse time being trying to talk to you. They would send a message into what they think is the future, but it would arrive in your past. By the time you read it, they'd already be moving backward through time, forgetting ever sending it. Communication would be like trying to shake hands through a mirror, always off sync, always elusive. Still, the implications are haunting. If time is truly symmetrical, and if consciousness can exist in both directions, then perhaps our universe is not alone in its awareness. Perhaps, alongside our forward-striving minds, there exists a mirror sea of reverse minds, thinking, feeling, dreaming, but in a cadence alien to ours. This would explain why no contact has ever been made. We look for signals in our timeline, expecting a message to arrive after it's sent. But a reverse mind would send before we ask, respond before we question, vanish before we understand. Even if such beings were trying to reach us, we might only catch their shadow, the echo of intentions we cannot decode. Yet, this silence might not mean absence. It might mean misalignment. Like two people talking on opposite ends of a film reel, each hearing the other's voice before the words are spoken. This raises a more personal question. What if part of our consciousness, perhaps buried deep in the unconscious mind, does operate in reverse? What if the brain, like the universe, is bilaterally symmetric in time, and some dreams, intuitions, or insights are bleed-throughs from our own reverse-flowing self? The ancient mystics often spoke of time as an illusion, of past and future as mere constructs of the waking mind. Modern physics seems to flirt with the same conclusion. And now, consciousness, the most intimate mystery of all, joins the dance. Not as a passenger of time, but as its sculptor. The universe we inhabit is vast, an ocean of galaxies scattered across the fabric of space-time, all racing away from each other as if propelled by an invisible force. For most of modern history, we assumed this was all there was: one universe, one arrow of time, one grand unfolding. But what if this is only half the picture? What if the cosmos is a mirror with two faces? Cosmologists have long been fascinated by the idea of symmetry. From the delicate balance of matter and antimatter to the elegant equations that govern forces and particles, the universe seems to favor patterns that reflect and repeat. Yet the flow of time, our most intimate experience, seems to break that symmetry. It flows only forward. Entropy increases. Stars burn out. memories accumulate in one direction only. But imagine a universe where time is not a river, but a pendulum. In this view, the Big Bang was not the beginning of everything, but the central point of a vast symmetry. From that singularity, two universes emerged, not one, but two, each expanding outward, each with its own arrow of time, flowing in opposite directions. To an observer inside one, the other would appear to run backward, like a film rewinding. This isn't idle speculation. It's rooted in serious cosmological theory. Some physicists have proposed that our universe could have a time-reversed twin born at the same moment as ours, but evolving in the other temporal direction. One such model suggests that time itself is an emergent property, a byproduct of the universe's geometry, and that for true balance, there must be a complementary universe where entropy decreases instead of increasing. In this mirror realm, stars would unignite, coalescing their radiation back into fusion fuel. Civilizations would deconstruct rather than build. Planets would unform, collapsing back into cosmic gas. But to its inhabitants, none of it would feel unnatural. To them, it would be their version of forward. They would age in what we call reverse. They would create history in reverse, and they would look to a future that lies in our past. Why haven't we seen them? The answer might lie in the nature of boundaries. The twin universe, if it exists, may be causally disconnected from ours. Like two bubbles expanding in opposite directions from the same origin point, they move away from each other, not just in space, but in time. From our perspective, they're heading into the past. From theirs, we're the ones disappearing backward. But could these two timelines ever touch? That's where things get fascinating. Some theoretical models suggest that at the moment of the Big Bang, or what's sometimes called the Janus point, the two universes might have been entangled in a deeply symmetrical way, not just in mass or energy, but in quantum information. If that's true, then traces of our twin could still be woven into the structure of our cosmos. Researchers have even proposed that certain features of the universe's large-scale structure, like the distribution of galaxies or the temperature fluctuations in the cosmic microwave background, might carry the faint fingerprints of this symmetry. It's as if we're seeing the distorted reflection of another cosmos in the ripples of our own. And then comes the provocative question, could we ever communicate across the divide? If time flows in opposite directions, then any message sent from our world to theirs would have to travel not just across vast cosmic space, but through the folds of time itself. To reach them, we'd have to send a signal into what we consider the past. And to receive their reply, we'd have to detect it before we even asked. Sounds impossible, but maybe not entirely. Some speculative ideas in physics, like wormholes or closed time-like curves, propose that shortcuts through space-time could, in theory, allow for limited contact between timelines. If a wormhole connected 2 points on either side of the Janus point, it could act as a bridge, a tunnel, not just through space, but through temporal orientation. Inside that tunnel, a strange thing might happen. Time would have no clear direction. An object entering from our side would emerge into a realm where causes follow effects in reverse order. An observer passing through might not even survive the transition, as their biological and cognitive processes struggle to reconcile incompatible temporal flows. Yet on the level of raw physics, the interaction could be possible. It's a terrifying and awe-inspiring idea. Contacting a time-reversed universe would be like trying to shake hands with a reflection. Every move you make is countered in reverse. Every word you speak is heard before it's spoken. And every attempt to understand the other is confounded by the very nature of causality. But the mirror may not be perfectly silent. There have been intriguing anomalies in our universe, puzzling signals, unexplained asymmetries, and rare particles that defy classification. Could some of these be the echoes of our twin? Glitches in the symmetry? Or even intrusions from the other side? Some cosmologists speculate that dark matter, the invisible substance that outweighs normal matter by a factor of 5, might be linked to the twin universe. Perhaps it's not just missing mass, but mass that belongs to a shadow cosmos, gravitationally coupled to ours, but flowing through time in reverse. If true, then every galaxy in our universe is dancing with a ghost, a backwards partner locked in cosmic synchrony. And then there's the idea of baryon asymmetry, the mystery of why our universe contains more matter than antimatter. Could this imbalance be balanced by a reverse version in the twin universe? One where antimatter dominates, but again feels entirely normal to those within it. This brings us to a radical possibility. Perhaps the laws of physics are not incomplete, but misunderstood because we've only ever seen them from one side. A full understanding may require viewing them from both directions. Time forward and time reversed. Our universe and its twin. Together, they form a greater whole, like the two halves of a cosmic DNA strand. Separate, but entwined. Opposed, but united. This isn't just a matter of curiosity. It could redefine everything we know. If cosmological symmetry is real, it forces us to reconsider the meaning of direction itself. Not just in space, but in being. Not just in entropy, but in existence. It suggests that our timeline is not privileged, but paired, and that every moment we experience is mirrored by another, unfolding in the other direction. The image is haunting. Two universes born in the same fire, drifting apart in time. One filled with stars that will one day die. The other, unweaving light into darkness. Two arrows of time, fletched from the same point of origin, flying away forever. And somewhere, across the divide, another civilization might be wondering about us, imagining our timeline as the backward one, searching for the same symmetry, asking the same impossible questions. Are we truly alone? Or merely half of something greater? Imagine if your choice today could rewrite what happened yesterday. Not metaphorically, literally. That's the provocative world of retrocausality, a strange and still controversial idea nestled deep within the baffling terrain of quantum mechanics. While it may sound like science fiction or a philosophical trick, some of the most intriguing quantum experiments of the last few decades have suggested that, under very specific circumstances, future events may influence the past. Let's dive into the rabbit hole. Quantum mechanics has always played by its own rules. In the quantum realm, particles don't have definite positions or velocities until you look at them. Instead, They exist in a blur of possibilities, a superposition that collapses into a specific state only when measured. But here's the twist. What if the choice of how to measure something, made in the present, somehow determines what that particle was in the past? That's the strange implication of experiments like the delayed choice quantum eraser. In this mind-bending setup, particles such as photons are sent through a system where they can take multiple paths. Normally, if you don't observe which path the photon took, it behaves like a wave, interfering with itself and creating a complex pattern. But if you do measure the path, even after the photon has already passed through, it behaves like a particle and the interference pattern disappears. Here's the kicker. You can choose whether or not to erase or preserve the path information after the photon has gone through the system, and somehow, this choice still affects the earlier behavior. It's as if the particle retroactively decides whether it came as a wave or a particle based on your future action. This isn't just a parlor trick. It's been replicated, peer-reviewed, and deeply debated. Some physicists argue this doesn't really mean the future affects the past. They say it's just quantum mechanics being non-intuitive. But others are more open to bold interpretations, ones that challenge the very directionality of causality. Welcome to retrocausality. This idea proposes that effects can precede their causes, at least at the quantum level. It suggests that the arrow of time, which feels so fixed in our everyday lives, might be an illusion produced by macroscopic conditions. On the quantum scale, time could be bidirectional. Events might be linked both forward and backward. Imagine a conversation not just between particles, but between moments. The future whispering into the past echoing forward into the now. Some of the most intriguing theories that embrace retrocausality include the transactional interpretation of quantum mechanics. Proposed by physicist John Cramer, it describes quantum interactions as handshakes across time. A wave is sent forward in time by the emitter, and a matching wave is sent backward by the absorber. Only when these two waves meet is a transaction completed, a particle is detected, and an event is finalized. If this sounds eerie, that's because it is. In this view, the future and the past co-author the present. A photon emitted from a distant star and absorbed in your eye right now isn't just a one-way journey, it's a negotiation across time. This flips our intuitive understanding of cause and effect on its head. We tend to think of time as a line with a cause at one end and an effect at the other. But what if it's more like a web, with threads stretching in both directions? This could have deep implications for the idea of a time-reversed universe. If time isn't strictly one way, even at the tiniest scales, then perhaps the barrier between our universe and a time-reversed twin is not as impermeable as we think. Maybe what we see as strange quantum entanglements and delayed choices are really leaks in the fabric of temporal causality, subtle hints of a deeper, more symmetric reality. Entanglement, for instance, has long been seen as a defiance of normal time. Two particles created in an entangled state remain mysteriously connected, no matter how far apart they drift. Measure one, and the other responds instantly, even if it's light years away. Einstein famously called it spooky action at a distance. But what if it's not spooky space, but spooky time? Retrocausal models propose that the correlation between entangled particles might arise not from information traveling faster than light, but from information traveling backward in time, back to their shared origin, then forward again to the partner particle. In this view, the effect precedes the cause only in our linear perception. In a larger, more complete picture, the universe is simply arranging itself in a temporally consistent way, just not one that respects our intuitive sense of time. These ideas are not just idle speculation, they're leading to real research. Physicists are actively designing experiments to test retrocausal theories. Some suggest subtle differences in statistical outcomes could reveal whether the future plays a role in shaping quantum events. And beyond physics, philosophers are beginning to take note. Retrocausality challenges the very core of how we understand reality. It blurs the line between determinism and free will. If your actions can influence the past, are you the author of your fate or just a participant in a script written from both ends? Even in classical logic, causality is the backbone of reason. But quantum mechanics doesn't always care about our logic. It prefers possibility over certainty, symmetry over direction, and sometimes mystery over clarity. This opens the door to profound new questions. Could an advanced civilization harness retrocausality? Could they send information backward in time? Could contact between our universe and its time-reverse twin be initiated through quantum feedback, signals planted in the past, destined to bloom in a different direction? Right now, these are only questions. But they are serious ones, increasingly explored at the frontiers of physics. As our understanding deepens, what was once dismissed as paradox may become paradigm. Retrocausality forces us to rethink the linear script of time. It invites us to see events not as dominoes falling in one direction, but as a dance of probabilities forming patterns across the timeline. And maybe, just maybe, it's the key to unlocking how two universes running in opposite directions could still be connected through the quantum fog. Let's suppose, just for a moment, that it's all true. That somewhere beyond the boundaries of our perception, or across an unfathomable symmetry of the cosmos, a time-reversed universe really does exist. That particles over there fall upward, stars unexplode into dense hydrogen clouds, and lives unfold from death to birth. What would it mean for us, not just scientifically, but personally, philosophically, and existentially? First, consider this unsettling yet awe-inspiring idea. We might not be alone in our direction of time. Most of us go through life thinking of the flow of time as an absolute morning follows night, cause precedes effect, progress moves forward. But if another universe exists where time flows in the opposite direction, that challenges everything we assume about our unique position in the cosmos. We are no longer passengers on a one-way track. We're just one half of a grander mirrored design. And here's where it gets really interesting. Could we ever cross into it? Not in the way science fiction imagines wormholes or black hole tunnels. Those are limited by space-time as we know it. But maybe there's a deeper symmetry, a quantum or cosmological interface where these two temporal rivers meet. Could there be a place, maybe near the Big Bang, or through some exotic particle interaction, where both universes brush against each other, whisper across the divide? Physicists Call this speculative boundary the Janus point, named after the Roman god, with two faces, one looking forward, the other backward. If true, it would mark the beginning of both universes, the moment they diverged, flowing away from each other in opposite temporal directions. Could we ever reach this point? Probably not physically. The thermodynamic costs would be unimaginable. Moving against the arrow of entropy would be like trying to unburn firewood. But in theory, or through quantum anomalies, could information be exchanged? If so, what would that mean? Would signals from the other side appear to us as strange, random blips, flashes of information we can't decode? Could this explain unexplained cosmic rays, odd neutrino events, or strange behavior in quantum systems? What if our scientific instruments, finely tuned to our forward flow of time, are missing the meaning in a backward-coded message? Now, think about contact. If we somehow made meaningful connection with time-reversed life, the implications would be staggering. Imagine trying to hold a conversation with someone whose memories are of your future and who sees your past as something yet to come. Communication would be not just difficult, it would be deeply paradoxical. You'd ask them about tomorrow, but to them, tomorrow is your yesterday. Your question would already be part of their history. Any answer they give might change your behavior, which in turn might change the question. It's a loop, AM-biased strip of logic that collapses under our understanding of causality. And yet, if retrocausality exists even in a subtle way, then some form of interaction might be possible, especially at the level of probability or influence rather than full-blown communication. Let's explore an even more mind-bending idea. What if we are already connected? Not through language or travel, but through the deeper structure of the universe. If the laws of physics are truly time-symmetric, if particles and forces obey rules that are the same, whether time runs forward or backward, then maybe everything we do ripples, not just into our future, but into the past of this mirror world. This wouldn't be the same as changing history. It would be more like co-shaping a larger, dual temporal reality. Our choices would define one side of the mirror, while theirs define the other, with both timelines curving together into a greater cosmic symmetry. And then comes the question that cuts deepest. What does this mean for free will? If there is a reverse time universe that is just as real, just as detailed, just as vast as ours, then are we just playing out one side of an equation? Do we have agency, or are we locked in a deterministic ballet with our inverted counterparts? Are we free, or are we dancing to the rhythm of a universe that has already decided how we end? Even worse, what if the universe we think is reversed is the real one, and we're the anomaly? These questions strike at the heart of human identity. They challenge our most sacred narratives about time, meaning, and self-determination. And yet, they also open a door to something rare, wonder. Because if it's all true, if the cosmos is balanced across a perfect axis of time, then our lives are not isolated. They are reflections. And in some profound, unreachable way, the moments we cherish, birth, love, discovery, are unfolding in another direction somewhere else, just as meaningful, just as mysterious. So what would it mean for us? it would mean that the universe is bigger than we ever imagined. That time isn't a cage, but a canvas. That reality may stretch not just across the stars, but across temporal dimensions we've barely begun to grasp. And maybe, just maybe, we're not the only ones asking these questions. Maybe, right now, in a universe where time flows backward, someone else is wondering about us. We often think of time as a river, flowing, continuous, unstoppable. But what if that river is not about movement at all, but about memory? Strip away the ticking clocks, the orbital dance of planets, and what remains? A single, startling idea. Time might be nothing more than the ordering of information. Let's look at the universe through the lens of information theory, the science of bits, codes, and patterns. At every moment, your brain is recording data. The light entering your eyes, the pressure on your skin, the thoughts forming and fading. Your sense of time's passage may be tied to how much information your consciousness is taking in and how it's being stored. Time, in this view, is not a physical thing, but a structure, a framework that lets information make sense. This perspective flips everything on its head. What if what we call the past is simply the part of the universe where information has accumulated, while the future is just the blank slate where data hasn't been written yet? Now, imagine a reverse time universe. There, information doesn't build up, it unfolds, unwinds, perhaps even erases. Memory could function backward. Instead of acquiring experiences, beings might shed them, drifting from high complexity to low. What we think of as forgetting might be their form of learning. This isn't just science fiction. Consider black holes, the most extreme information vaults in the cosmos. According to classical physics, anything that falls into a black hole is gone forever. But quantum mechanics insists information cannot be destroyed. This contradiction gave birth to one of physics' greatest puzzles, the black hole information paradox. Stephen Hawking once proposed that black holes leak radiation, Hawking radiation, and eventually evaporate. But if the black hole disappears, what happens to the information inside? Is it scrambled into the radiation somehow? Or is it lost, violating quantum law? Some physicists now believe that the universe protects information at all costs. Time, then, is deeply tied to how data flows, gets preserved, or becomes inaccessible. From this angle, entropy, that relentless increase in disorder, might not just be about heat or chaos. It could be the rate at which information becomes harder to retrieve. This idea stretches into the core of quantum mechanics. In certain interpretations, every event is a kind of update to the universe's information state. Each measurement collapses possibilities into a fact, carving out what we call now from the raw potential of the future. And here's where things get truly mind-bending. If time is an emergent property of how information is processed, then it's possible different universes, or even different regions of the same universe, could process information in fundamentally different ways. One flows from low to high entropy, another from high to low. In that world, time could run backward, not because clocks tick differently, but because information moves in reverse. Let's make it more tangible. Think of a movie being played on a screen. Forward, it tells a story. Reverse it, and the same data appears absurd. Broken glasses reassemble. Rain leaps skyward. People walk backward into birth. But from a purely informational standpoint, both directions are valid sequences. The meaning only emerges based on the context and on where the observer perceives themselves in the flow of data. Could we then switch contexts? Could an intelligence in a reverse time universe interpret our history the way we interpret theirs, as a coherent structure just viewed from the opposite end? And if so, could we one day translate between time directions? There's also an unsettling implication. If information is central to time, what happens when we lose information, when memories fade, archives burn, or signals decay? Are we, in some sense, shrinking time? Does the loss of data pull the past further from reach, making the universe effectively younger? Some researchers have even proposed that the present is constantly being updated, a kind of computational refresh of the universe's state, like a simulation. In this view, the passage of time is simply the evolution of information states in a vast cosmic algorithm. And the arrow of time? That's the direction in which those states grow more complex. Reverse the computation, and you reverse time. It's a radical thought, but not unscientific. The more we study black holes, quantum entanglement, and cosmological entropy, the clearer it becomes. Time and information are inseparable. We live in a universe that seems obsessed with remembering. From the fossilized bones of dinosaurs to the fading light of distant galaxies, everything around us is a record, a message written in the language of time. But what if some parts of the cosmos aren't about remembering? What if they're about forgetting, unstoring, simplifying? In such a realm, the future isn't something waiting to happen. It's something being carefully undone. And maybe, just maybe, understanding this could be the key to decoding time itself. Time, for biology, isn't just a background setting, it's a lifeline. Every living thing dances to its rhythm. From the sleeping cycles of bacteria to the slow aging of trees, time pulses through the veins of biology like a hidden metronome. We are built for forward time, wired, evolved, and encoded to age, adapt, and reproduce in a world where yesterday leads into tomorrow. But now, let's take that lens and flip it. What does biology look like in a universe where time flows backward? Let's start small. Cells in our world age. DNA accumulates mutations. Proteins unfold. Skin wrinkles. Life is a cascade of irreversible chemical reactions moving in one thermodynamic direction. But in a reverse time cosmos, those processes would unroll in reverse. Molecules would de-age, entropy would decrease within organisms, and death, from our perspective, would mark a strange kind of beginning. Think about evolution. Natural selection depends on variation, replication, and inheritance, all playing out across generations. But in a reverse time universe, what does natural selection even mean? Would it operate in reverse, with organisms shedding adaptations instead of gaining them? Would complexity unravel instead of increasing? Would reverse evolving organisms be drifting not toward survival, but toward what? simpler ancestral forms? Or perhaps toward a shared origin encoded in their version of the future? It's not just about survival anymore. It's about regression as progression. And what about reproduction? In our time, a sperm and egg unite to create a zygote that multiplies and differentiates. In a time-reversed world, would the process be inverted, a body breaking down into smaller, more primitive units, eventually returning into a gamete-like state? From our point of view, birth would appear as a strange, systematic collapse. Then there's the matter of memory. In our biology, memory is a product of change, synaptic strengthening, neural encoding, experience layering over time. In reverse time beings, memory might work by unlearning. Perhaps their minds grow simpler with experience. Their past could lie in their future, with identity gradually stripped away, not built. From our perspective, they would seem to grow more naive, not wiser, as their lives progress. Even the concept of learning might be foreign to them, or inverted. We adapt based on feedback. We try, fail, adjust. They might start from solutions and move toward uncertainty, reverse experiencing every failure after every success. Would their version of wisdom be a clean slate? And don't forget metabolism. Our cells convert food into energy, burn fuel, produce waste. It's a forward-ticking chemical engine. But reverse metabolism would look like a miracle. Waste reforming into food. Energy concentrating instead of dispersing. Digestion that pulls material into its original components. From our vantage point, it would look like time itself rewriting biology. But perhaps the most haunting question is this: could life as we know it even function in reverse time? Or is biology, our biology, an artifact of this specific direction of time's arrow? We evolved in this thermodynamic current, using entropy as a ladder. Strip away that flow, and maybe life simply can't emerge. Not because it's impossible, but because it's meaningless without direction. Yet nature rarely draws lines it won't cross. Some theorists argue that biological systems are fundamentally information processing structures. If that's true, and if reverse time universes process information differently, as we explored in Part 9, then life might still emerge, just not as we understand it. It might not be made of carbon. It might not even be made of matter, but it could still evolve backwards, simplistically, beautifully, toward a kind of origin we can't begin to imagine. And here's a twist. Some physicists argue that the universe itself is a kind of computational entity, a quantum system evolving through states. In this picture, life is just a pattern writing that computation. Reverse the computation. And who's to say a different kind of life couldn't ride the wave back? In the end, biology in reverse time forces us to confront a deep bias, our assumption that life must grow, expand, and remember. But what if forgetting is sacred? What if simplification is just another path to transcendence? What if the story of life in a backward universe isn't a tragedy, but a return? Long before equations hinted at the possibility of reverse time, stories did. Ancient myths, modern films, cryptic poems, across every culture and era, humanity has flirted with the idea of time unraveling. not just as a science fiction twist, but as a deep emotional metaphor. In art, reversed time isn't just a thought experiment. It's a language of longing for lost moments, unspoken words, chances that slipped away. Take storytelling. Most narratives move forward, beginning, conflict, resolution. But what happens when you flip that? Consider films like Memento, Tenet, or Irreversible. These aren't just gimmicks, they're psychological detonators. They force us to reconstruct meaning from the end backward. Time becomes the puzzle, and comprehension becomes an act of mental reversal. But the fascination runs deeper than cinema. In some interpretations of Merlin's myth, the great wizard lives backward through time, knowing the future but blind to the past. His tragedy isn't in powerlessness, but in inversion. He remembers what we have not yet done and forgets what we've already lived. It's an eerily elegant metaphor for what a reversed time consciousness might feel like, knowing ends before beginnings, but helpless to change them. And then there's music. Reversed audio has been a haunting motif since the invention of the phonograph. Play a record backwards, and you conjure a sense of the uncanny familiarity collapsing into surrealism. Yet, it's more than eerie. Composers like Karlheinz Stockhausen and even the Beatles experimented with reverse sound, not as trickery, but as structure. Music becomes temporally unanchored. Melody unfolds from resolution to tension. It challenges us. Can beauty still exist when causality doesn't? Visual art has explored this too. Think of video installations where footage runs in reverse. A glass reassembling, a forest fire, sucking flames back into the trees. These works don't just reverse motion, they reverse meaning. Destruction becomes creation. Loss becomes gain. The direction of time is not neutral. It defines what we consider hopeful or tragic. Now, imagine a culture that lives in reversed time. What would their art look like? Would their novels begin with deaths and end in birth? Would their painters depict futures already known, memories yet to be made? Would they value the unmaking of things, sculptures that collapse elegantly, songs that deconstruct themselves, stories that dissolve? To them, creation might be entropy's undoing. Sculpting could be about restoring raw marble from form. Music could recover silence from noise. Even emotions might be inverted. Nostalgia for things that haven't happened yet. Grief for things yet to come. And their language? Perhaps their verbs would run in reverse to unsee, unfeel, unchoose. What we call growth, they might call release. Their moral tales could revolve not around becoming something, but returning to what they were before identity formed. In such a culture, time's arrow wouldn't guide meaning. It would reverse it. Which raises a haunting question. Are our artistic instincts fundamentally time-bound? Do we love stories because they echo our lives? Linear, irreversible, finite? Do we find catharsis in endings because we're racing toward one? Maybe art is our way of softening the brutality of time. And maybe imagining reverse time is how we rebel against it. Yet there's a final twist. Some of our greatest artistic achievements already hint at timelessness. A symphony's beauty isn't in its direction. It can be played, replayed, reordered, and still move us. A painting exists outside time. A poem is a loop, not a line. Perhaps these are our closest bridges to a reversed time perspective, moments where we step outside the flow, where sequence dissolves and something eternal glows through. So if a being from a reversed time universe encountered our art, would they understand it? Or would they feel what we feel when we watch their stories run backward, a kind of recognition that defies logic, rooted not in time, but in truth? Because maybe that's the secret. Maybe time is the medium, but meaning is what crosses through. As we wrap up this journey through the mysteries of time, we are left with one profound question. What if time isn't what we think it is? From exploring the possibility of a time-reversed universe to questioning the very nature of causality, we've delved deep into theories that challenge our fundamental understanding of reality. The idea that time may flow backward, that cause and effect could unravel in reverse, forces us to reconsider the very fabric of our existence. Could time be an emergent property, something that arises from deeper, undiscovered laws of nature? Or is it, as we've always believed, a one-way street dictated by entropy? Though the notion of a time-reversed universe remains speculative, it compels us to think beyond the boundaries of conventional physics. The universe, in all its complexity, may hold secrets we're only beginning to glimpse. Maybe time isn't just an inevitable flow, but a cosmic dance, far more flexible and symmetrical than we imagine. The mystery of time, after all, may be far from over. And perhaps the most intriguing question remains: is time really one way? Or is there more to the story than we've ever known?